Hi, so now we are ready to do the experiment. So I'm on the page 49 on the lab manual, and then we need a mountain post with clamp and hook, chain with ring. So here we have a mounted pendulum. I'll show you in a second after I close my sharing screen. So then we're going to try this part one of the experiment, so dependence of the period on mass. And you'll be seeing a second video for the part two of the experiment, which is the dependence of the period on length, right? So I'll be sharing the data with you after I completed the video here, and then you can work on your lab report. So let me stop sharing my screen, then I'll go to the experimental setup here. So as you see here, there's a pendulum that hangs from the clamp, and here we attach a 50-gram mass here, and here we have a photo gate that's measure the time period. So we can do like, maybe you can do it like using a stopwatch. You can count the oscillations and measure it. So one oscillation means, one period means the time that the pendulum takes to complete a full cycle. So let's say you're starting counting your oscillations over here using this position. So let's say that's the starting point. So we'll wait until it's go all the way back of the swing and come back to the starting position. So that's a one oscillation. And that's the time period means the time it takes to oscillate one cycle, right? So the time it takes to the pendulum to go from here and come back to its initial position. That's a one oscillation. So if you want to measure the time period manually, then you have to count like 10 oscillations, calculate the time, and take the average time period. So here we are not going to do the measurements manually. Instead, we are using a photo gate that it's measure the time for us. So when it's passing through it, it will wait until it's completed one cycle, and it does measure the time period for us. So here on the capstone, as usual, we have the on-build capstone file. So this one will collecting data, the time period for oscillations. So we will be waiting until it's count about 10 oscillations, and then we take the average time. And I'm going to share that data with you. So you're good to go with the first table, data table 1, where we're going to measure the time it takes to oscillate for 50 gram mass, and then 100 gram mass, and a 500 gram mass. So we're going to analyze the time that takes to oscillate these masses, right? So let's start with 50 gram, and I'll share the data with you later, like after I done collecting data for other masses. All right, so let's try this. So what I'm going to do is I'm going to start recording data. I'll let this one oscillates, and then I'll start collecting data here. Maybe you can see it. So it's counting the time, right? Here, it's counting the time for us, and it will calculate the average time period after it's completing about 15 oscillations. Well, so that's what we're going to do. Now it's oscillating badly, so I should have stopped recording data. So anyway, I'll share the correct time period with you, so you can do the analysis there. Then I'm going to repeat the experiment with 100 grams. So I will hang the 100 gram, and I will oscillate it through the photo gate. So make sure that it's not crash onto the photo gate, so it's disturbing our measurements. And also when you're making the angle, it should be a small angle. The theory is valid only for small angles. So if you keep like about 10 degrees, it's great, and let it oscillate, right? So that's what we're going to do. So we oscillate it and then record it for 100 grams. Okay, wait until it's complete about 10 oscillations or 15 oscillations, then we stop counting the time. Okay, as I mentioned, I'll share the data with you. All right, so we're good. So it's recorded about 10 oscillations now. And for this 100 grams, the time period is 2.0 seconds, right? So it's 2.0 seconds for one oscillation with the hanging mass of 100 grams. Then let's do it for 500 grams. Now I have to adjust my photo gate because it's this is a little longer. See, like it's crashing there. So let me go a little lower here so it's not crash onto my phone again, and then I oscillate it, and then I'll record the data for the 500 gram. All right, so I oscillate that, and then I record it. Right? So likewise, you do the experiment, and then you record the data, and then you are ready to answer the question 1 and 2 under the experiment. Okay, so then when you're working on question number 2, it's asking about the gravity on the moon is about 1/6 of that on Earth. So you know Earth gravitational acceleration is 9.8 meters per second square. On moon, it is less than that, and it is 1/6 of Earth gravity. So it's 9.8 divided by 6, right? So that's the gravitational acceleration on moon. And the question is asking you to calculate the time period for this same pendulum if you perform this experiment on moon. So you may use the theoretical equation given on the first page, where T equal 2 pi square root L over G. L is going to be 1 meter. Maybe I forgot to mention, so this length of the pendulum is 1 meter. All right, so I'll see you in the second video with part 2 of the experiment.